Okay. Looks like we have some people still coming in, but I guess we can start in a few seconds. Okay, well, welcome everyone here to the FMEA Software User Insights with the background of our AS13100 and RM13004. I'm Jonas Nickel. We have Ebru Cetin here from MTU Aero Engines and John Rizzo from Pratt Whitney. I think we can then start going through our presentation showing what we're going to show you today. Yeah. So just you probably have seen it. We are going to record the webinar today, so also so that you're aware that this is being recorded. It's going to be put on YouTube later on, just in case you're missing anything or your connection has an issue. But other than that, I think we have a reasonable attendance. Ebru, do you want to take us through the numbers?
I cannot see them because I have the poll here.
All right.
But I know in total we had 49 registrations last week. So a lot of people from the States and from Europe. So, and from the other countries, at least 1 or 2 people. Here you can see the overall registrations.
Yeah. Yeah, we've got 21 people from the US, 1 person Canada, 2 from Mexico. Looks like 9 from the UK, 10 from the rest of Europe. Yeah. 4 I think looks from India and 2 from China. So a pretty global representation. Thanks for everyone for joining. And yes, then let's move on to what we're going to cover today. You see overall the AESQ, in case you are joining such a webinar for the first time, is a very widely spread organization and has a whole number of companies that are involved. And so we're trying to be covering the aero engine industry as widely as possible. Okay, so we can do some introductions.
Okay, yes, then I will just briefly talk about myself. My name is Ebru Cetin, and I have been working in the quality methods department for more than 2 years now. And I am responsible for the preventive methods, especially for the process FMEAs. I'm also a member of the subject matter interest group of RM13004. And before I joined the quality methods department, I wrote my master thesis on the introduction of reference process FMEAs at MTU. And I also supported the introduction of the IQS software in the company and supported the implementation of a closed loop principle.
Thank you. Yeah, and I'm going on next. I'm Jonas Nickel. I'm the manager for safety analysis at Rolls-Royce Deutschland. I've been working in Rolls-Royce Aerospace now since 11 years. First in quality and for the last number of years in safety analysis. I have also 9 years prior to this experience working with FMEAs, DFMEAs, mostly in the automotive industry. I've been part of the RM13004 subject matter interest group pretty much since the early days when it became a reference manual and moved away from the AS standard. And I've been one of the co-authors of the 30004 DFMEA section. At the moment, I'm managing the safety analysis team here in Rolls-Royce Deutschland. So you will see some of the aspects that are more design and systems related from my side today, as that is my sort of key field in terms of DFMEA and FMECAs.
So, muted at the moment.
Seems to switch on. Let me know if that happens again. Thank you. Reshare. I'm the manufacturing and engineering discipline chief for global supply chain here at Pratt & Whitney. I have 18 years at Pratt in design, manufacturing, and sustainment. Been working with manufacturing readiness levels and a subject matter expert on the DoD working group. I'm also a member of the SAE G23 subcommittee for manufacturing management, as well as a recognized expert and a approver for process flow diagrams, PFMEAs, and process control plans at Pratt & Whitney, both for some of our internal development applications as well as for PPAP.
Thank you, John. So today we'll have split the webinar in 3 sections. So the first one is having a quick recap on FMEAs using RM13004. And after that, we'll move over to the main section, so where we're going to cover some of the specific software insights. We're not going to demo large portions of any of the software packages that our companies are using. We're going to show bits and pieces to illustrate practical examples. You will find abilities how you can build simple DFMEAs, simple PFMEAs, and the like, usually at the manufacturer's websites. And SDASQ is a vendor-neutral organization. We will not endorse any specific software here. We'll show what to pay attention to and how we've and our different companies tackled certain challenges in the usage of the software. So the first one is selection criteria. So how do we select software? What are key features? If you're shopping yourself, what you might want to pay attention to? Action management. So we've covering some aspects of creating tracking actions. Also, how could that interact with project and task management? We're touching on supplier integration, some of the challenges of sharing information with various types of suppliers. Then how can different types of FMEAs interact? How could that look like in such software? And then we're covering lastly the reference PFMEAs, so benefits. How do we get to closed loop feedback and part families? And then there's a last section that's covering questions and answers that you might have as we're going through the presentation. Yeah. So AS13100 has in the main standard, you see it's as you can buy it from the SAE website, is more an additional to the usual ISO 9000, EN 9100 quality manual for aerospace companies. It specifies items specifically to aero engine manufacturers and has a few top-level requirements for FMEA, but references mostly to the RM13004 Defect Prevention Quality Tools Reference Manual, which is available for free for download at the ASQ SAITC website, and is quite extensive in terms of how the various defect prevention tools interact with each other. Okay, John, do you want to? John, do you want to cover this, or should I?
I can certainly cover this, Jonas.
Yeah, sure.
So here's the FMEA requirements and guidance, and it's a image straight out of the 13100 document that really shows the 5 phases of APQP, starting with planning through product design and development, onto process design and development, into process and product validation, and lastly into phase 5 for process control. A lot of what we're going to be going into detail on in today is really focused mainly on the FMEAs that are spread throughout all of the phases. But it's really a key thing to understand that these software packages that we're going to be discussing and kind of reviewing at a high level today really relate to a lot of the activities beyond just the FMEAs, and help control the documentation, as well as to interact the interactions between DFMEAs, PFMEAs, system FMEAs, FMECAs, and others as well. So I want to start by introducing really the evolution of software relating to failure modes effects analysis. Almost everyone starts with just a spreadsheet, either in Excel or some other tool. That's really a no barrier, no cost entry-level solution that allows you to quickly and easily understand how to utilize the tools and the techniques to score the risk and to really prioritize what you're doing. From there, people tend to move up to a basic database that really stores the spreadsheets themselves and allows some additional organization and record keeping on what a business might be managing as a whole for all its products. From there, they start to go with increased and integrated databases that starts to add reporting infrastructure and initial integration with other business processes and methods before they go into more well-established software tools that carry automation and collaboration with different FMEA modules. This adds even more integration to things, allows for collaboration to happen more effectively, and additional levels of reporting as well. And this tends to be the line between the integrated databases and these automated solutions that split between homegrown and really we're procuring a software solution and a service. And then the last one is integrated modules and APQP software. This is really things that are driving more end-to-end solutions with lifecycle management, service integration. Some of them are starting to even integrate with model-based definition and MBDMI, as well as blockchain enabled, where if you make a change one place, it will automatically recognize that that's changed and allow the different folks that are seeing that to react to it. The bottom line here is that the software solutions can be scaled to fit the size, the skill, and the needs of a business, and that they all add some level of benefit, but they're not all necessarily equal in terms of what exists. So we'll start with a very quick poll. We're wondering how you are using FMEA software. So we should see a quick pop-up coming up soon relative to whether or not you're using Excel only, software with local storage, a software with centralized storage, or an integrated APQP or liability engineering data flow using all along the entire value stream.
It seems not to be working right now because it says unable to send poll. But maybe just type in the numbers into the chat and I will try to recap, try to count them.
All right, thanks, Ebru. Okay. We'll give it a couple seconds there for the team members to go plug that in.
So at the moment, we have a lot of ones. Only 1, 3. Okay, 2 times 3 and 1 time 2.
All right.
Okay, so at the moment there are more than 10 times no software used. 3 times we have the third option, and option 2 was only chosen once or twice.
Okay, thank you, Ebru. I definitely think that's a good outlook, and I think that matches my experience and what's going on around the industry. So our next topic is software features. So I'll give that back to Jonas to start to cover.
Okay, thanks again. Just a quick disclaimer. We do have a few examples here. The software packages that we have and that we'll mention are basically the ones that we are using at our companies. It doesn't necessarily mean that we're endorsing one specific software or another. We've counted, I think there was something like 24 different solutions on the market. So there's a good choice what you have. But I would like to also cover a little bit from a sort of as neutral as possible standpoint, what we believe are important things to consider when we are selecting a software. Many of you have chosen one, so probably quite a few might be wondering what are things to consider and what are potential benefits. You would go to the, see if I can, yeah. So as we've just discovered, most organizations start with simple spreadsheets. Ideally, they're already a bit standardized, which is easy, and it's a quick start to doing the PFMEAs in an organization. Many of you might have discovered that it's difficult to manage those at scale, especially when you talk about a larger project with a few hundred engineers. You'll see that they tend to invent new columns, different scoring schemes, and you end up with a divergence of spreadsheet formats. You will also find very often that there's a little or almost no reuse of FMEA data below the spreadsheet level. So when you try to integrate that, you'll find that some people, let's take something like high energy debris, you might find HED, high energy debris written out. You might find burst, you might find all kinds of descriptions that if you try to accumulate that across a large program, this is really, really difficult to keep track of. And one of the main benefits is when you use software, and one of the ones that almost immediately materializes is that you can professionally manage your FMEA activities. You have an improved standardization of your templates and scorings, depending on how you set up the software. We can give people a little bit of freedom or next to no freedom usually. You can enable the reuse of either entire FMEAs or the corresponding FMEA elements. In quite a few packages, you can also start to link between different functions and failure modes so that you start to get a line of sight and say, okay, where does this even come from? And why is, for example, in my PFMEA, that failure, that manufacturing non-conformity linked to a severity 10 on the product side? Okay. If we then go to the features, I've grouped that a little bit into sort of essential features that are really useful, and then some additional considerations that you might want to have a look for. So one thing that I personally believe is and I think we all sort of when we exchanged the softwares that we use is essential, is that you have server-based FMEA repository that allows you to have proper access rights management. You might not want to have every user with all access rights in every project. That can have the simple data hygiene reasons, but especially in our industry, there are probably certain projects that you do not want everybody to see or to work on. And therefore, such access rights management is extremely helpful. Aligned with that is the ability to have different user roles. So some people are authors. Some people you might want to share and say, okay, I want a lot of people to read the information, but not necessarily modify it. You might want to give certain people approval rights. So to say this is an FMEA that has been reviewed and considered to be useful for the next steps. And another factor is then concurrency. And what I've seen is that there are also different levels there of concurrency that are possible. So we can have this as a repository. So the database allows you to work on multiple people. That's sort of the given minimum, which is different than if you would just put something on a drive. You might already have the access. Like let's say you would put all your FMEAs into one single huge Excel spreadsheet. In the old days, having that open by one person on the drive without having that shared spreadsheet means nobody else can work on that. So not very useful if you have a few hundred people needing to do that work. The next breakdown level is then if you go into the project level and say you're working that, or ideally you can also have granularity on the record level. The next thing that is essential is that you have configurable scoring. So one question there would be, can you adjust it to the RM13004 standards? We've seen that the standard is still relatively new, that not all of the software vendors have adjusted that to some peculiarities that RM13004 has in terms of scoring tables, for example. So you want to pay attention to the ability to have that. Certainly, automatic calculation of RPN and action priority is necessary to ensure consistency and avoid manual errors. Also, I think that's something that I've seen most vendors do today is that the ability to go from RPNs to action priority, something we're not going to cover in great depth today. But just for people who aren't that far along on their FMEA journey, RPN is not necessarily the recommended way to score your actions and prioritize them. Action priority is the much more preferred version. The latest version of RM13004 has adjusted that already for the PFMEA. We will likely include that in a later version for DFMEA, also at least as an alternative method. The next thing is to have the ability to have different templates and views so that you can configure to your DFMEA, PFMEA, to FMECAs. Can you have all the columns that you want in RM13004 without getting overwhelmed with hundreds and hundreds of possible data fields that your team has? And then I'd say it's so good that I think it is good to have made it rightfully its way into essential features, is that you can have configurable catalogs to say, here are short lists, prompt lists for failure modes, for effects and causes. It helps for consistency and speeds up the process of writing an FMEA without limiting people if it's not an exclusive catalog. And then for RM13004, especially for the PFMEA, you need to be able to implement reference FMEAs in one form or another. And John and Ebru are going to cover that later in this webinar. So then the next item is for product or process structure. You should be able to reflect your product structure, your configuration. So you have to think about a bit how you want to do that. Do you want to do it on a module level, on an ATA chapter level? Do you want to have a functional breakdown for your product? There a quick recommendation from my side. Try to use something that's invariant. So do not pick organizational lines or the current work streams in your NPI program, in your new product program potentially. you might find that you have to reorganize your FMEA structures sooner than you'd like to. Same thing on the process side. You would typically, as a larger organization, might have more than one plant where you manufacture items. Then you have to think about, do you organize it along the various plants, process flows, part number specific FMEAs is a strong recommendation in RM13004. So the structure should be able to support that. Okay. The last feature that we think is absolutely essential is that you have some form of versioning and approval and retention. So the software should be able to track changes. You might have to decide how far do you want to go. Do you want to have every single record that gets changed being recorded? How far back do you want to go ever since the database was started? Do you just want to look a year back or so? I think there's, John, could you go back one moment? I think that's thank you. And then versioning is very essential. So can the FMEAs be frozen in version so that when you go back after 3 years, say, okay, so what was the FMEA we used at that time? Approval is not necessarily something there, but I think it is helpful if it's available. So are there workflows and roles? Very important is, from my experience, that you have a concept for retention. So can you make your records immutable by access rights or by design of the database? You do not want unintentional changes later on. And how do you link this to your long-term archiving concept? Okay. A bit into the additional features. If you are integrating suppliers or vendors or have to supply something yourself to a customer, it is extremely helpful if you have an FMEA import and export through a vendor-neutral format. So it could be a classical Excel file format or an XML file. This is something that I would recommend to talk to your supplier about. How can they make that possible? It does not help you if you have a wonderful software, but there are limitations in how you can exchange your information. It might be fine if you do not have any external integration, but it's certainly something to pay attention to. Then, as Jonas said, the tendency is going to go into further integration, so enabling model-based systems engineering. So it would be great if the software can integrate with your CAD system or your general product lifecycle management or your requirements management software, so you get more and more data items linked up. But as we are in a regulated industry, the ability to create some form of formal report is often still there. So does the software support that? Can it create printouts? Can it create maybe formats that are aligned with what you're using internally? That's a really helpful feature to have. And how does linking between the individual FMEA records work? So DFMEA to PFMEA between systems along the product hierarchy is helpful. Attendance records, most guidance recommends that you record what you have when your sessions are going. So you should be able to document the sessions ideally within the software, not have to keep that someplace else. And then for quality checks, having checklists, evaluation options is something that is really extremely useful as well. Finally, there are a few soft factors that you should consider. One is usability. So how easy is the software to use? Is it a steep learning curve? Do you need to send somebody to trainings, or is it something people can pick up? Also, if you want to use it in the workshop, it's a small comment from myself. Often for brainstorming, I've found it's actually better to still go back to a bit more classical moderation method and then do the transfer after the fact, rather than having an individual demonstrating their skills using Excel or the software tool or whatever. Then the next step then is support. So can you build a relationship with the supplier? or are you linked to a just more or less just the hotline? Can you talk to the people? Can you get feature requests incorporated? As I said, there are many vendors on the market. It's still a very dynamic environment. And I think we've all found that having a vendor that you have a good relationship enables you to actually get some of the things that are specific to you incorporated. If you're a multinational organization, you would also want to look into language handling. So can the worksheets of use be localized to help team members who might not be as familiar with English as you might be, especially in the manufacturing world, that can be very helpful. Because a lot of people who you might want to ask on the shop floor might not necessarily be as conversant as you are. Zoom function is something that is sounds a bit like nice to have, but again, if you want to use the software in a workshop, if you've ever tried to do an Excel spreadsheet on a classical video projector, you probably know what I'm talking about. It's not a lot of fun if you cannot Zoom. So with that, we can come to the next poll. So Ebru, you've probably prepared that. Let's see if it works this time around.
No, it's not working. So that's why I will have an eye on the chat. Okay.
So we asked basically what software capability or features do you think is most important to your business? Is it that you can have is it product or process structures? Do you want to centralize and use central storage? Is it action management? Are you looking for integrated APQP? Is it the training? Are you interested in easy user interface or other items?
Okay, this time it's a bit harder to find out which number is chosen most often, but I would say 4 is mentioned very often, and 6. We have 7 only one time. What else do we have? 3 was mentioned also. So it varies between 3, 4, and 6. And we have also 1, 3, 4, and 6. So very balanced between those.
Yeah, so standardization, action management, the integrated APQP data flow, and these user interface. So any of the vendors are listening, I guess that's going to be very educational to see what they have to focus their efforts on in the future.
Yeah. Okay.
Okay, then over to you, Ebru.
Yeah, so as mentioned, so we have action management on our agenda today. So I will start with the action management in IQS. So in IQS, we have 3 options to do the action management. I would like to briefly show you in theory what options we have, and then I will go into a demonstration directly into the system. So the first and the easiest option is to go directly into the browser view of the measures or the actions. Here you can see very clearly which measures have been assigned to you, and you can display and edit them directly there. So you do not have to go into the software, you have a browser access, and I think this case is really user-friendly to get started. The second option is you just open the IQS system and go to the module Action Management. This is very similar to the browser view, except that you have to enter the system directly. But you have an advantage here that you can directly jump into the FMEAs. So if you need further information for this action, then you can just click in the system and open the FMEA. And the third option is you can directly open one specific FMEA and just have an overview which actions are listed for this FMEAs, which actions are still open, or is the FMEA completed and all actions were completed. So I will just go into the IQS system and share my screen at this point.
Yeah, it looks like we might have lost the audio here.
Okay, Teams kicked me out when I was sharing, but you can hear me now?
Yes, we can hear it now.
Okay, then
Yes,
let's give it a try one more time. Okay, it works. So I was just talking about the FMEA I wanted to show you and how to handle the actions in the system. So I've set up a very easy example for you. It is about the operation 10, CNC drilling. The requirement is a diameter and failure modes are too big or too small. You can see here. I have also added some effects such as scrap part, and I've added one cause, which is part loosen fixture. We can have a look at the FMEA form here. So I have added.
Sorry, it looks like your screen's not coming through. So I thought it was just me.
Okay, you cannot see the screen. That's not good. Strange. So I will just stop sharing and share one more time. So I have the red frame, so it seems like it's working, but you cannot see it.
No, not at the moment.
Okay, I think that's nothing I can change right now because Teams says it's working for me.
No, it does.
Yeah, we just got it.
You can see it right now?
Yes.
Yeah, it just came up. Go ahead.
Okay, then it's just way slower than I was expecting. Okay, then I will just go to the FMEA form here. So you should be familiar to this FMEA form. So I was talking about the diameter, which could be too big or too small. And as a cause, I choose part loosen fixture. As a prevention, I added none. So we don't have a prevention here. And as a detection, we have a bore micrometer at the operation 50. What I want to show you is that I have added an additional prevention action here. So we had none before, and now we have maybe an air detection system on fixture. And I gave it a deadline for today, and the responsible person is also me. What I can do now is I have this FMEA open, and I can open the view action. So here I will get a list of all the actions which are created in my FMEA. So we will have an overview of all unprocessed actions, and we can just double click on it and then change the status, for example, from unprocessed to completed maybe. But I will just go back to my FMEA. So this is a very good overview of what actions are still open in my FMEA for my part 1. The second option is we can go into our module action management. I have it already open. The difference here is I can see all my actions which were assigned to me. So not only the air detection system on fixture, which was in my part 1 FMEA, I also have more than these two more actions from different FMEA. So this would be a complete list for me to just see what kind of actions do I have in my IQS system. And the last option was the browser, but I only can show you some pictures here. So the browser version is almost the same like the action management module. You can see all the actions here, but you do not have to enter the system. And it's way more user-friendly because you only have a very clear view of your action here, and you can change your status from in process to completed maybe. But here in this case, you do not have any access to the FMEA from the browser view. But all 3 options are synchronized, so if you change it in the browser, it will also be changed in the IQS system. Okay, then at this point, I will stop sharing and hand over to Jonas. You're muted.
Thanks. I want to cover on a slightly different part of the action management. I can also show a quick review on the Action Explorer that we're using in our software XFMEA. The user interface looks a bit different, but the fundamental functionality is usually relatively the same. I just wanted to highlight something that I found was important as we in our team have numerous tasks that need to get done. So updating FMEAs is one item, or having actions out of them. In many teams, you also have to then coordinate that with other design activities or safety analysis activities, manufacturing activities. So there's one decision that you have to make, and that is, do you want to run basically the action system integrated? Do you want to run differently? And so I just want to show a little bit what we're doing to sort of integrate that a little bit into the wider workflows here in that given example. So in this case, it is more specifically for the FMEAs that we manage. And the concept that we have is that in principle, everybody can in principle say, okay, I have done some work. I found something that I think while I was using the FMEA that does not quite reflect what I think what happened, what I might have seen. Could be an outcome also of maybe a service investigation. There are many reasons why you might think that there is something that needs a review or an update. And as we're also obliged to actually keep our safety analysis current and up to date as a product goes through many decades of service, we've set up a system there where a user can actually raise a ticket in a separate ticket systems. We've actually used some form of bug tracking system here as a basis. So there are also, again, many of those on the market. In order to open that up and basically have a web-based interface, so where people can then feed items into that system. And then one of the safety analysts can pick up that ticket look into this and say, yeah, that's credible or that's not credible, or I'm missing information. And then starts to go to the FMEA software to address the ticket. And modify that. And as that is then updated, we then use the versioning of the software to have a reviewer who can then say, okay, I agree with the analysis results, and close that ticket in the corresponding ticket system. So it's a bit of a closed loop around this. And when you're setting up your system, it's just something to consider, how you want to integrate this. Do you want to have this up front? Do you want to run this maybe through some form of Kanban board in parallel? Do you want to run this all through the FMEA software? So there are many variations, but I think it's something that is quite relevant to think about when you're setting up your overall process. Okay. And then that gets into supplier integration. And John, that's over to you.
All right, thank you. So next topic is supplier integration. First, want to start with supplier management and product and process development. So some of the key things to really understand and focus around to manage that relationship is having a common language for the product and the process. The FMEAs and the software often give that infrastructure to easily and readily communicate back and forth utilizing a common language. The next key factor is to maintain alignment and make sure that we're all understanding the level of risk in the product and in the process is early and progressive communication regarding the product requirements and some of the process requirements as well. So it's really important to start with whatever minimum information and data you have that might support a prototype, and then use that to leverage into a pilot line, and then use that into validation of a production facility or production line as well. And then the last piece is comparison to similar parts, similar products within the supply chain, or leveraging past data using PPAP. So a lot of these software tools become the library or the body of knowledge for what can be done, and allow you to navigate what's similar about a process or about a component, and use that as a comparison at a individual supplier, at a component level, or even at a process level. So it's really important to understand and have that organized so you can effectively manage that. Using FMEA software specifically for supplier integration, the primary function of a lot of these FMEAs are to document the risk and to really make sure that we're reacting appropriately where risk is identified through one of the actual FMEA tools, as the design authority or the producing authority or whatever scope of authority you have. In addition to that, its secondary function is maintaining alignment and making sure we understand what are the requirements, what are the risks, and how do we react appropriately together. So at Pratt & Whitney, we utilize a lot of these packages to represent what are the requirements and share some of the risks between stakeholders. So we identify what are the DFMEA key characteristics and the things we've got to control more tightly, and we make sure that our supplier producing the product understands that and can react to that appropriately. We also use it to improve design and process integration, where there's feed forward and feedback loops based off of process capability at a supplier to incorporate design changes, or to allow us to figure out how does a process have to mature to support the overall rate or quality signature that's desired between the design authority and the producing center. We also use this really as a fundamental way to communicate process challenges and compare to things, as well as support integrated planning of risk management to really align to analysis between product and process change. Often a high risk requires reaction both by the design authority and by the producing facility. So it's really important to understand what types of actions can happen and how do you brainstorm, and then down select the one or the multiple actions that are going to add value.
Okay. Yeah, one of the topics in terms of supply integration is that I want to cover is integrating engineering suppliers. So just so to be clear on the definition, those are typically companies that provide design, analysis, or other engineering services on behalf of the manufacturer, and that requires a number of considerations. If you think about locations, so where are people, what hardware do we use, what's the situation regarding intellectual property, security, and export control. And at least in the history that I've been part of, there's been a bit of an evolution. So a few years ago, I've seen that we still had sort of very sort of offline people being on site, being basically on-premise suppliers. That made actually integration relatively easy. So you'd know the person, he or she would sit next to you, get company hardware, and just work basically as if they were just one of your team. That came with a number of challenges. One is, of course, that doesn't scale on a global organization. Another one is, at least in some countries, that became a bit of an issue regarding is this person actually an employee or is the person not an employee, and caused all kinds of other issues. And then additionally, there were, especially for people who were there only short term, there were always some level of security concerns. So the next step, I've seen people then got a bit moved off premise, but received a company laptop so they could dial in using that, still basically being like a remote employee, which removed some of those concerns, but not all of them. And so you still basically have a full company access with such a fully equipped company laptop. Then it comes a bit to a break. And if you then go to a company that's further away, you can't use that. Have often enough had situations where you just end up exchanging files. And that can be very painful, especially when you have to synchronize it back to a centrally managed repository. So in many cases, I've seen now that companies go to virtual desktops so that effectively you sit in your own IT environment, but you can log into the virtual interface of the OEM and work there through some form of secured platform. And that is, at least for the applications that you've been approved of and that you've been secured for as a supplier, makes it possible that you can work almost as integrated as the people who were on premise some time ago. There are some challenges, though, that have to be managed, especially when you think about offshoring or a multinational environment. If you quickly go to the next slide, thank you. So if you then have taken here an OEM that sits in the EU as an example, you might have several projects set up in your repository. In this case, I use the term also to explain a little bit. Repositories and the projects are the terms used by the vendor that we use. So in FMEA, these are the units that we can mean. That does not necessarily mean engine project or whatever you're working on project, but allows basically a segregation of the repository into different isolated chunks. Then depending on where your supplier sits, you might give them access to one project or multiple. What we've seen, what is basically giving you the best initial protection, is to think about that you build up user groups per supplier per region. So supplier 1 and region 1 is one user group, supplier 2 in another region is another user group. and so on, and you give each of them an individual project, or whatever the mechanism is that you might be using in the software. There are a few other mechanisms that are available, like applying licenses directly in the software. That depends a bit on what you're using. But that's usually a safe baseline in terms of IP, also cross-company IP, and in terms of export control. But of course, that then means that you have to find ways how these projects can talk to each other across the different lines where you need that. And therefore, it makes, of course, sense to combine projects based on the contracts, the data, and the available export licenses. And I've set up a little example here to take this away from the abstract into something that's a bit more concrete. So let me see if I have more luck here with sharing my screen. So please shout if it's not going live and I'm dropping off. So here in this very simplistic example, I have basically a repository here in our software. That's the XFMEA screen. So I have a DFMEA project that covers integration for some pressure system. And I do have a supplier. In this case, I've just taken one supplier who has this work package to work on one specific item out of the system. So here you see I've sort of made up a bit of a very simplified hierarchy. Effectively, the supplier is working here on one package, which is the cover plate. So that's something that they're using separately. So the way this is set up now, without going into too much detail how the software actually works, is if I then look at how this project here itself is set up and configured. And I just wanted to very quickly just explain a little bit how that then works from a security perspective. I basically here have now in this project, in the work package, I have my power users, I have my supplier, and I have my normal users. So people who are full-time employees can fully work in this project and basically also help people move data in and help people to configure this. The supplier, on the other hand, if I go back here into the main project and look at the security settings there, you see it has been blanked out. And how that then looks if you apply that in real life. So let me just quickly click through this. So you not want to bother you with too many of these details. So if I will now run as one of the suppliers here in the project, you can see that the overall project is gone, and I can now work in here in this sort of localized area and more or less feed that information into this project. Now that just remains then the question, so how does the information come back to the main project? And that's again something that I will very quickly show you when I'm back with my full access rights. So this cover plate that I had mentioned here, you see that in the structure there's if there's an FMEA available. So this box is currently empty. There are two mechanisms in this software. I'm only going to quickly explain one to show how that is done. Again, it depends on what software you're using. So the mechanisms will be slightly different. But if I now add an FMEA, there is a way I could link it hard, but there are reasons that I'll explain later that I'll actually use a localized FMEA to add to the software. Sorry, and that was the wrong system. That was me talking, not looking where I click. Sorry for that. So here's my cover plate with the corresponding image for my little pressure box that I want to design with my team. And what I can do now is I can transfer. So it's a form of linking functions from somewhere else. And I select the package that I have here. So the supplier work package cover plate, I want to use the function contain pressure. And basically function should stay functions, failures, effects, and causes the same. And if I now read this across, I have now basically my main repository and my main project where the full-term employees are working can see all the higher level hierarchies. For example, here there's an FMEA covering the pressure vessel as a whole assembly. And they can work on all of this and at the same time see what the supplier is doing and if something's changing. In this case, it's marked with little traffic lights. Again, other softwares have other mechanisms. Just want to show you that if you configure your projects in that way or your licenses in that way, there are ways to enable your engineering suppliers to actually work directly, usually in an enterprise system, without being able to see the rest, but you being able to integrate everything into one single package, which I think is one of the big advantages that I wouldn't know how you would do that concurrently with a simple spreadsheet-based version. So certainly something that whoever you're going to talk to as your vendor, something you might want to ask for. John, you dropped a mute.
Yes, thank you. I'll learn that by the end of the webinar. So the types of PFMEAs, we're going to go through and some of those. Integration between the different types of PFMEAs using some of this software. So that it's really a cycle. So starting with a systems failure modes effects analysis, moving through a design failure modes and effects analysis into the process, and finally potentially into the equipment, which is really just a specialized systems FMEA used within a manufacturing facility. So the purpose of all of them is really identifying the key, the critical, and the special items that have to be treated throughout the PFMEA, and making sure you can react appropriately to all. So the starting place is always this functional assessment, where you might identify one or two major or critical components. And within that, you'll start to analyze the DFMEAs for those to create what are the key and the special features and characteristics there that you'll then assess on the PFMEA for what are the process characteristics and controls that are required to manage that in a production facility. And finally, looking at it from a standpoint of where are there high risks and what requires control within the process itself. You may promote some of those into an equipment failure modes effects analysis to create a more robust way to control things, or to really design the right systems requirements for capital equipment, for an inspection system, or for a machining CNC system that identifies what type of control does part probing or on-machine fixture probing provide in terms of equipment, and how does that relate to your PFMEA, and is that also a control that even the DFMEA can take credit for? So it's really important to recognize the relationship of what's major and critical and key to each aspect about those, and then tie them together, either utilizing a software, or in an Excel example, you're just going to have to comment things to show the integration and the connection between them. Jonas, you're on mute as well.
Dropped on mute. Interesting. It does that to me too. Okay, so when you then think about the different FMEAs, that's very interesting to start linking those. So ideally, if you would want to have, this is just a small cutout out of a much larger vision. But if you think about your flow for starting from your model-based systems engineering, where you identify your product and your system functions, you set up your initial requirements, probably use a system FMEA to iterate those, then develop this further down to your subsystem DFMEAs and your part DFMEAs, And from there, you can then go to your PFMEAs and your FMEAs. And it enables you to have good information sharing and also a flow of data between the different user groups. If you achieve that, you have good consistency across the entire value stream for analysis. Also, though within one FMEA project, so the view where it's one bucket, you might still have the same FMEA type. So, for example, a DFMEA, but you want to be able to link between different levels of hierarchy. So as you go from your systems to your subsystems, from your subsystems to a part, or from an assembly process to potentially what would that mean for part PFMEAs? You can start to drive certain requirements and certain functions and failure modes down between the hierarchies. Once you then go from one type of FMEA to different ones, at least that's what we've seen, is you often need to then configure your data items. So in this case, it's projects slightly differently. That has to do often that the template scoring, the standards are a bit different, so you have to adjust that. But there might also be reasons that you have different end user groups. One example that I can bring is that when you have a plant that has, for example, let's say a specific casting process that might be particularly IP protected or even under higher levels of export control. You might want to limit that core IP to the folks who are in your plant and not necessarily want to take that much outside of out of that user group. On the other hand, if you're talking about certain certified failure analysis, like certain types of FMEAs, you might want to share that wider in the company to make it available for people to digest and analyze. So depending on your scope, you probably would want to change that a little bit. And with that, I'm just quickly jumping back into that example that I've built to just show you a little bit of a glimpse of how that could look like. Obviously, we're not going to do software-specific detailed training here today, but to give you a bit of a feeling of what you can do. So in this case, you've seen we've had here a little supplier integration here. If I then take my pressure vessel and I see my body still doesn't have an FMEA. So what I can do now is do something very similar to what I've done with my supplier. I could just transfer. In this case, I said, I don't want from the cover plate, but from the pressure vessel, it's a level higher. I do want to have a bit of a different adjustment, so I don't want to have a one-to-one relationship here. My functions probably would stay the same. My failures might actually be causes at the higher level. Effects are going to stay the same, and the causes at the component level are things that I still have to identify. So if I then create that relationship, so at the higher level, let me just quickly show you. I had a very, very simple example. So I said, okay, I want to contain pressure in my pressure vessel, and I might have a minor leak with a gradual pressure loss and a major leak with a burst, with a cause that my strength or of the structural parts is not sufficiently specified. So typical design cause. If I then go now to the derived record, I've inherited the contained pressure. I see here strength of structural parts insufficiently specified. Does not necessarily help me here in this case. High energy debris is there, so I have to modify that just a little bit. I take that and will modify that for the cause. Here in this case, my failure actually is likely going to be some kind of crack in the pressure body. But I can retain this and then modify my cause and say, for example, that I would say that the wall thickness of my pressure body is insufficiently specified. So again, one can discuss many things on how you set this up and how you change that. But now I have basically have a very simple sort of multi-layer DFMEA with several suppliers. I can now take that and start to actually move that also over into a PFMEA. Again, have a bit of a different mapping here in this case. So I've created it here. I'll change something that's a bit software specific and change that into a different category, just that it's a bit nicer to see. As I now log into my PFMEA, I can see here that I have now for a pressure vessel, body, and cover plate, I have initial FMEAs where I say, for example, okay, so a function is not defined because it's going to be some form of manufacturing process that I have to use. My wall thickness insufficiently specified. Remember, this was a design cause, so I can specify it incorrectly, but I can also manufacture it incorrectly. So I start to get an idea when the PFMEA team picks that up, what I have to think about here in terms of causes that could lead to this form of product effect. And very similarly, I could then also derive an FMEA structure out of this. Going back here, just very quickly, as I said, this is just a quick demo how something like that can look like. So in this case, you'd say, okay, your functions will likely stay the same. The failures will stay the same. Effects, causes, I don't really need for an FMEA. I can create that, assign this to a different grouping. And again, have more or less an initial structure that then allows me, as I then go into the FMEA with a different profile, I also have, this is what we're using, I also have then the possibilities to define alphas and betas to build a numerically sound FMEA that I can also use later on to things like fault tree analysis. So the mechanisms, if you're using a different software, are most likely going to be a bit different. But you start seeing with those connections that you can actually go back and jump to the different areas of the hierarchy and create a line of sight between your different instances of FMEA that are all talking to each other. And I think this is, in whatever form your software is doing, that is something that I believe is one of the strong items that you get out of going outside of the Excel world with things stored to different drives into an integrated database project.
Okay, thank you, Jonas, for your insights. And I think I need the next slide.
Yeah.
Because on this topic of different types of FMEAs, I would like to show you one example how to take information from the DFMEA and put it into the process FMEA. So in IQS, we have one option which is called hybrid FMEA, which means that the design and the process FMEA are created in one document in IQS. So we have lots of pros here. So when creating both methods in one document, then it's possible that we can focus on one effect and can see all the causes of the process and of the design FMEA. So we have one failure network, which is really huge, and you can have all the information at one side. And what also works good is that you have the functions and the failures are only described once, and thus it's easier to ensure that it's the same wording for both methods. And the last point is that if we have only one document per component, it contains all the information about the component, and this may make it make the organization of the documents clearer, and in total we will have fewer documents. But if we have only one document for both, there will also be some restrictions. So an IQS document, maybe, for example, can only be edited by one user at a time. So if the design and the process team are not the same people, then we cannot edit the document at the same time. So only one user can work in the document. Then we have also maybe some issues with the rights setting regarding reading, writing, deleting, and releasing rights, for example. They can only be managed once per document. And in a hybrid FMEA, it's not possible to separate the rights according to the design or the process team. So if you get a writing right or access for the design, then you will automatically get it for the process FMEA as well, because it's only one document. And we have to think that we have very complex products in aerospace. So even a single process FMEA or a single design FMEA can contain so many system elements, so many failures, maybe hundreds or even thousands of failures and functions. So it could be very complex and not really clear if we have only one document for both methods. So that's why we came up with a different solution at MTU. So we therefore create two separate documents for the design FMEA and for the PFMEA. So as soon as the design FMEA is at a certain stage, we copy all the information from the design FMEA into our process FMEA document, and then we build up the process FMEA on top. So I will try to share my screen and show you how it really works in practical. Okay, it seems I'm still here. Just a short feedback if you can see my screen.
We can see it.
Okay, perfect. So I have created a very short design FMEA. So my part is called part 3. I will open the FMEA form. So we can see here on the top right that my failure is, or that we have a cause that the diameter is too big, then the life will not be achieved. And as an effect, we will have a disk burst, for example. So what I do then is going into my newly created PFMEA. I will copy into my PFMEA. I will then copy my design FMEA I've just shown you into my, I have to take the effects, and I will copy it into my process FMEA. So I have the contents of my design FMEA in my process FMEA. And on top, I will just put my process FMEA we create with all the team members. But in this case, I will just take our process FMEA from before our drilling. So now we have two FMEAs in one document. But in the beginning, we had two separate documents. So what is the benefit? When we are finished creating our process FMEA, we can search for our requirements or failure modes. So for example, diameter too big. We know that if our diameter will be manufactured too big, maybe we will have a scrap part. But what happens in flight? So we can get that information from our design FMEA. We can search for the diameter in our design FMEA part here. We can have a look at our failure network. And we see, okay, if the diameter is specified too big, it will lead to a disk burst. So what am I doing? I go back to my process FMEA form. I know the effect I need. I will take disk burst and put it into my effects column here. So I just looked up what will happen if my diameter is manufactured too big. So we will have a disk burst, and I automatically get my severity as well, which was defined in the design FMEA. So that's how we connect the information from DFMEA to PFMEA. So I will give back the screen then to Sean again.
All right, on to our next topic of reference PFMEAs. So wanted to take a little time and go through building reference FMEA strategies. There's two main schools of thought when we look at part families and process families that are utilized in automotive in particular, but aerospace is also starting to really explore it. They all start with a group level where you might have metal fabrications. They then work down to a subgroup level where there might be a difference between aircraft level components and propulsion level components. And then you break it down into farther detail relative to part families. So under aircraft, you might have doors that are metal fabrications and heat exchangers that are metal fabrications. And in propulsion, you might also have heat exchangers, but you might also have tube support brackets that are also fabricated. In these situations, you should be trying to approach the part families from a similar function or features method, and also look at it from the standpoint of production and inspection. Some generic examples that exist within the propulsion world in aerospace, parts often break out into round components, like cases or shafts or rotors, and prismatic parts that do not fit into that same general category. So brackets, heat exchangers, things that tend to be more blocky in nature, gearboxes would fit in a similar category. We also utilize process families at Pratt & Whitney. So that's where we're using similar inputs and outputs. Some examples there relate to processes that use the same equipment. Again, it's formatted in a group, a subgroup, and then a process level. So within machining's group, we have a conventional machining and an EDM subgroup. And below that, at the process level, you might have multiple different types of conventional machining. So turning, drilling, milling. The two examples on the slide are sawing and cutoff. And looking at what that means, you probably have very similar controls for conventional machining in terms of feeds, speeds, depths of cut, as well as failure characteristics where abusive machining is probably related in both, and you'd want to represent that within the PFMEA, and that may also feed up into your DFMEA, depending on what might be the problem in terms of the material characterization or in terms of the design integrity. Next, I want to kind of highlight more of a trade study and a case analysis that we've done internally. So the benefits using these reference FMEAs, using some sort of hierarchy based off of features, allows for a more robust initial PFMEA. It also supports knowledge capture and transfer and coordination between process and product subject matter experts that may not be available on site while you're producing your FMEAs. It's reduced development time as well, enables process improvement and technology read across, where you might identify a root cause and corrective action in one PFMEA, and by following it up in the tree, you could figure out where else it would add value for the business and quickly leverage that across. It also promotes more standard identification of failures and risk assessment and management overall, where you can draw much more clear lines that highlight where actions have to be taken and where there might be pre-existing best-in-class practices that you want to leverage forward in a new product design. The graph on the right-hand side of this table is really showing you the analysis we did for multiple types of processes. We were able to produce more than 50%, more than a 50% increase in number of items identified through the FMEA versus just small sub-teams creating individual FMEAs. Right, back to you, Ebru.
Okay, thank you. Then let's see how MTU handles reference process FMEAs and the closed loop. So as you already mentioned, John, for us, the initial situation was that we really invested a lot of time in creating FMEAs, and these were done not really comparable to each other due to different teams. And this led us then to set up a project in which we created reference FMEAs. So the aim was that we could use these reference FMEAs as a catalog to derive specific FMEAs more quickly. And the goal was that then they would be of a higher quality. On top of this, we also had the opportunity then to implement a closed loop principle. This is about keeping the FMEAs up to date and constantly feeding it with new inputs. These could be new experiences, new processes, new designs, or even problem-solving methods, such as 8Ds, for example. So just using all these updating triggers to update our reference FMEAs. So in our case, we are only updating our reference FMEAs, and then the specific FMEAs automatically get updated because they are connected to each other. And I will show you an 8D as an example and show you directly in the system how we set up the reference FMEAs and how we create specific ones, and then also the input. Okay. So I have as an example a drilling reference FMEA. So this works as a catalog for us. So this is only in sections, but I have put in here diameter, length, position, and as causes I have drill oversize, spindle not running through, or part loose and fixture. So we use this reference and create our component-specific FMEA. So I go into my component-specific FMEA, and what I do is I open my reference FMEA and just drag and drop my drilling into my component-specific FMEA. At this point, we have to specify our PFMEA, such as adding our OP numbers here, or deleting or adding new requirements, or going through my causes and to the prevention and detection measures. And we have to have a look at the occurrence and the detection scorings if they are correct for our component-specific FMEA. So specifying this FMEA. So that's how we use the reference FMEAs to derive component FMEAs. What then also works is if we start an 8D, a problem-solving method, we can use the failure field here in our step D2, and I just click on my 3 dots here, and I can see all my FMEAs. What I do now is I will use my reference PFMEA drilling. I will just click through the system here, and I will see all my requirements here. So just think of one failure we could analyze in an 8D method, maybe a scratch on the part. So I will have to choose one of these requirements where it fits best. So I just click on no damage maybe. I click on next and put scratch here and finish. So what happens here when I just save my AD? So they will analyze and will finish their AD. But if I go to my reference catalog back, I will see that the scratch automatically will be shown up here in my no damage requirement. What I can do now is I can confirm this failure here, or this failure mode here by clicking on that. I can save it and I can release a new version of my reference catalog. So I will say version 2 and say yes. Now, if we have a look at our component-specific FMEA we just created with our reference, we will see the scratch automatically appears here. So when we had created our component-specific FMEA, it's like an inheritance. So we inherited the reference drilling to our component-specific FMEA. So they are connected to each other. And every time I change something in my reference FMEA, it will automatically be shown in my component-specific FMEA. And that's how our closed loop system works. So we are always updating our references, and then it will be automatically spread to all our component-specific FMEAs, and IQS really helps for this procedure. Okay, then I think that was our last topic for today. We had a lot of input, and we will go into our questions. I already saw some questions in the chat. Maybe I will just read them. We have one for the supplier topic, I guess. Should suppliers purchase the same software as the OEM for better importing and management? I foresee a substantial increase in costs to complete a PPAP. Who can answer this question from us three?
Yeah, well, I can probably take first step, and John can then take your view of
Sure, I
this.
can add, yeah.
Yeah, I think that would be excessive if you've seen that each of us uses a different software. So if let's say MTU, Pratt, and Rolls-Royce were your customer, then you'd have to buy 3 different packages. So I think it's very clear you would have to synchronize. It's very clear that that's not reasonable to expect. Obviously, whoever talks to you first will most likely convince you to try to use the package that they have so that the exchange is as easy as possible. I personally think that what is more relevant is really to make sure that the software vendor helps you and enables you to have a good data transfer bridge, as I've said before. Even if it's an Excel sheet, which is probably the most ancient form, it does help. Better, of course, would be some more modern format that can be automated accordingly. I think that would be clearly one of the demands that I would have. Do you have this, or how fast could you put that into your software version to integrate with all my customers?
Yeah, Jonas, I definitely agree with that, and I think the business case that the supplier has to be able to put together has to add value. So if the software that all have slightly different cost profiles isn't going to pay off internally, it's not something that the leadership of that company and supplier is going to actually invest in. So I think fine-tuning that and recognizing what's an acceptable cost to be incurred to really manage your business and ensure that the software is adding value and not actually costing the business is really important to understand. Rolls, MTU, and Pratt Whitney all work together on different products, and we often integrate using the same software packages We use communication devices and I think translation devices like Excel as a pass-through to make sure that we're on the same page with what's going on. It's more important that the supplier has flexibility in understanding what's important to us, and that they can communicate effectively with our tool. In most cases, Excel is the lowest of common format, so that tends to be where I think we all meet in the middle. But I think it's certainly a discussion depending on if the supplier works more with MTU than they do with Rolls. It may make more sense to invest in what they're doing, as well as if you have some delegated design authority. So I think it really depends on the total scope of what you're looking for in the software packages, and how much communication you're looking to have, where you may actually look to feed information up or down between the supplier and the OEM that may happen separately from just an Excel email.
I hope that answers the question. The next question is, can then different customer-specific projects share the same reference FMEA? Maybe I can start from MTU point of view. We only have, for example, one drilling reference. So we use really one reference for all customers. So you can create different reference FMEAs. You can create variants, for example, for different customers. But in our case, it's easier to create only one reference for all different programs, because when creating the component-specific FMEA, you always have to check if the reference is correct or if you have to delete or add something. We don't want people or teams to just copy the reference and then let it as it is. So in this case, we are very conservative and say, okay, the team members have to think through the complete FMEA one more time and go through the points, and then it's easier to only have one drilling reference, for example, and use it for all components we have. I think this also goes hand in hand with the next question, but John, or do you have something to add for the references here?
Yeah, I can definitely add to that. So I think from an APQP standpoint, absolutely. You want to share and interface with as many of the reference PFMEAs or FMEAs as possible, and sharing those is definitely optimal. I think the challenge is when you're going from the early development and optimization phases into validation and verification within PPAP. The expectation of the PPAP tools is that you do have specific detail relative to the components that you're maintaining approval over. So you can have similar materials that are cross-referenced from others, but I think it's really important to recognize that the expectation in terms of a delivered product for PPAP is not necessarily a reference PFMEA. You'll need to make sure you're post-processing it and that it's representing some of the same DNA or in the same constituents of the reference, but it is also looking specifically at what is the severity based off of the design requirements that are unique, as well as what might be unique in your facility relative to producing that part.
Okay, thank you. The next question is, I think that's for me. You are changing the reference FMEA due to a customer escape, but the occurrence is only increased in a specific part number. This is like working with a family PFMEA that we are finding it difficult to be approved. So I think the answer is almost the same from my side, because if we have one customer escape, we always assume that this escape could also happen to other components from different programs. So that's why we really put it into that only one reference FMEA and spread it to all specific FMEAs, so the responsible persons have to think of, could this also happen to me? So it's like a lessons learned. So we spread all the information to the whole company, to all components. We have PFMEAs for, and then the people have to think of, do we need that input, or they can even delete it if they say, okay, in our case, the occurrence is so low that this cannot really happen for our component. But the first step is always spreading the information to all. You have something to add, maybe?
Ebru, I think I can add a little to that as well. So I think when we talk about read across and we talk about things that are identified with a customer escape at a specific part that you're then going to promote into a part family, you're recognizing a potential defect and a cause of failure that might result in an escape. So I think from a severity standpoint, that's very clear. In terms of detection, you can measure within the PFMEA what that actually meant. So I think the detection score and the severity score would be promoted effectively. We do want to be very careful about the occurrence scores because the population will ebb and flow depending on volume requirements. Newer product might be ramping up, so you would expect those occurrence rates to potentially increase. And when you're ramping down on a product because it's decreasing, the opportunities for those defects to present themselves might be changing. Typically at Pratt, we do not promote the occurrence score itself. We do occasionally look at it from the entire part family, but in that situation, one escape might still be such a low occurrence rate that it's not going to represent flagging a global action by, let's say, a fellow or a subject matter expert. So I think it's important to make sure that the part family strategies that are being leveraged are not necessarily driving bad actions in the business, because what you measure is what you're going to react to, but recognizing that usually the part family, the part specific, is what you want to react against.
Okay. Next question is, with different software trials, we have detected that if we add any additional line into a part-specific PFMEA, the link to a reference FMEA is lost. So this drives us to the initial situation of managing thousands of sheets that have to be maintained alive. If I understand that right, yeah, that's correct. From IQS side, you cannot send inputs from the specific FMEA back to, there is no back loop to our reference FMEA. So if you add something new to the specific FMEA, then it's separated, then it's not inherited from the reference. But in this case, maybe we should think of, why don't we add it then to our reference FMEA if we need it in so many specific FMEAs? So then we have to think of a really good part family procedure, or adding it directly into the reference FMEA and not to only one component specific FMEA. So if I understood the question right.
Yeah, I wasn't quite sure. That might be good to have some clarification, because I was wondering if it's that you cannot read it back, which is something that we also observe in the software that we have, that basically reestablishing links or basically bringing lessons learned back is not yet built in. That's probably something that it's good to talk to the suppliers about. If it breaks the link to the reference PFMEA completely, so that also for the other lines it's lost, that might be something where I think the way that you suggested, Ebru, might be a way forward. I would also think that that might be something that's well said, where the relationship with the software vendor comes in, to go back and show that to somebody close to the development team there and say, okay, do you have an answer? Could you provide an update? Then because I think breaking the linkage completely would be certainly not a very desirable feature. But I'm not sure if this is really just that you can't read it back, or if the complete linkage is lost.
Okay. So maybe I can just show the reference one more time. Okay, it worked. I will use the color modus inheritance in my component-specific FMEA. So here you can see that this is red and has a blue frame, which means it is connected to my reference because I put my drilling into the specific FMEA. So if I add maybe more causes here, cause 1, 2, 3, then we will see this will be red now. So this is not linked to my reference because I have additional information which is not in my reference FMEA. But all the other things which are green, they are still connected to my reference FMEA. So only this one additional point will not be connected. So was the question that the linkage completely will not be there anymore, or only for this one part, or only this one cause here? So in our case, in IQS, it's only for one line. The rest will stay the same and will stay linked. So if I change something in my reference, or drill oversize and add 1, 2, 3, save and release it, it will automatically be shown in so many pop-ups. It will automatically be shown in my component-specific FMEA. Here, as you can see, the 1 through 3 was added, so it's still linked. The other lines are still linked, but not the new one I have newly added. Let's stop sharing.
Yeah, I can confirm that in software we use XFMEA, you'd also lose the something the added at the layer below would not be read back, but you would not lose the other links. Not sure, John, how that is in the package that you're using.
That's also an anomaly that we have to manage using business processes within Pratt for Datalyzer. So I think that's probably common across a lot of the platforms that exist. And I think it highlights that we provide constant feedback and requests from the software provider to help alleviate those and restore that actual desired capability. But it is something that if you feel is really critical and crucial for your business and is what's going to add the most value, that you choose based off of that in your analysis.
Okay, one question is more organizational. Yes, we will share this presentation and the recording on the ASQ website. Okay, that was all from the chat. Do you have more questions? And just raise your hands right now. Okay, I think that's it. And we have only a few more slides to give you some more further information. There's one remark in the chat. It would be useful if AESQ could organize a practical exercise or training on an FMEA software. We can take that with us and discuss it in our subject matter interest group maybe, but maybe that's really hard to define one software because all softwares are so different.
Yeah, but we can take it back and see how we can do this in a way that sort of doesn't distort the market. Yeah.
Yeah. Okay. And we will think of that. Okay, so the last slides are further information where you can find some guidance. So we have a reference manual. We already talked about in the beginning. You can download it free of charge from the AESQ website. And we also have our subject matter interest group to support the deployment. So the subject matter interest group is are some experts from different aerospace companies. They come together and develop materials to help the companies to deploy the AES 13100. So you can also contact us through the AESQ website. And we also have a community of practice on LinkedIn. We have a 13004 community that is open to everyone. Just join it and ask questions if you have, also on LinkedIn. And on the next slide, you can see how you can find us on the website. So if you type AESQ, you will find the landing page, and on the top of the landing page, you will see the activities, and under that, you will see the subject matter interest groups, which then takes you in the middle picture. And at the bottom, you will see that there are the different subject matter interest groups, and here you can also find some contact information. And then I also, next slide. I can also remind you of the last of the past webinars from our subject matter interest group. So we have 6 recordings here, and one is the latest one is from assembly. So PFMEA for complex assembly. It would be the 7th one. So you can also have a look to these ones here to overview of PFMEAs, design FMEAs, and also how to reduce human error with FMEA method maybe. And on the next slide, I think this is not the latest pack at the moment, but there's also an events page. So we are still working on new webinars, and we will have an action priority webinar in this year, or we will also have a process flow diagram and characteristics matrix webinar this year as well. So it's worth keeping an eye on our events website. And that was the final slide for today. Thank you for joining, for getting involved with us, asking questions. And we do hope that it was really interesting for you. And also thanks to Jonas and John.
Yeah, thanks, Ebru, thanks, John.
Yeah, thank you both.
Yeah.
Thank you
that's it
for
for
attending.
today. Thank you.